Hello, geometry students, and welcome back to another video lesson where we continue using our triangle congruence theorems and proofs. I just wanted to make a shorter video today to walk you through two more examples of proofs, walk you through my thought process, what I'm looking for. Again, we have a quiz coming up on Friday where this will be helpful. So here's the first proof. Given the diagram below, H is the midpoint of MK and QD. We need to prove that triangle QMH is congruent to triangle DKH. And so we're going to try and set up a proof, two-column proof with our conclusions and justifications. And as we look at this, we're trying to prove that two triangles are congruent. This means we need to use one of the four SSS, AS, AAS, one of the four triangle theorems. All right? We need to use one of the four as our last step. SSS, side, side, side. Side, angle, side. Angle, side, angle. Or what would the last one be? Angle, angle, side. So we're trying to get through this diagram to show that. Now we're given, remember, number one is always the given, so we should write that down. We're given some information that helps us. Number one over here. H is the MP, midpoint. H is the midpoint of MK, comma, also QD. And so it is the midpoint of both of those. And if it's the midpoint, we have to then come up with a statement from that. We have to use that information. And so if H is the midpoint of MK, we know this segment is congruent to that segment. So we should write that down, that MH is congruent to HK. How do we know that's true? Well, that's the definition of midpoint, which they told us it was a midpoint, so we can use definition of MP, or midpoint. Now, we can also put on this same line that if H is the midpoint of QD, I know that segment is congruent to that segment. So I'm going to put that right here underneath. QH, that segment is congruent to HD. Same exact reason, definition of midpoint. Now we've got a side and a side are congruent to a side and a side, so we need something else. Well, I notice in this picture, I've got two angles across from each other, or that this angle has to be congruent to that angle. So angle MHQ is going to be congruent to angle DHK. Hopefully, we remember what those two angles are called. That would be vertical angles, or the vertical angles theorem. And now I've got a side angle side with a side angle side. Side angle side. So there's our justification, side angle side, that the two triangles are indeed congruent. Triangle QMH is indeed congruent to triangle DKH. So we had to go through the process, this proof, of showing what two sides were congruent. And we knew that because they didn't tell us the sides were congruent. They just told us that there was a midpoint. So I used that definition of midpoint to show that some sides were congruent. I also looked visually at the diagram to see that I had some vertical angles. Vertical angles are congruent. and we were left with side, angle, side. Next one. Given that we have a circle with a center C, we want to prove that segment XY is congruent to ST. We want to prove that that's true. All right. I'm going to try and type this one out. So we've got some conclusions. And then we've got also some justifications. When you look at the fact that they gave you a circle, that's your clue. Just like in the last one, how they gave us the midpoint, we have to realize that that's kind of the clue. So step number one here. Given circle C, meaning there's a center at circle C, our justification for the first step is always given. All right, now, numero dos. Because I know that there is a circle, what we can do is we have to use the definition of circle. Because they tell us a circle, it is a circle, I need to use that as a reason, as a justification. And the definition of a circle says that any point on the circle is equidistant from the center, meaning from C to X is the same distance as C to Y, which is also the same distance from C to T, which is also the same distance as C to S. Because those points are all on the circle, they're all the same distance away. And so right here, we can say that CX is congruent to CY, which is also congruent to CT, which is also congruent to CS. And that was all because of the definition of a circle. Now, again, the hint is that they're telling us it's a circle, so we should use that. So now I've got side and a side and a side and a side. But before I can prove that parts of the triangle are congruent, I've got to be able to show that two triangles are congruent. How do I get two triangles yet? Well, once again, we've got vertical angles. Angle XCY is congruent to angle SCT. Why? Vertical angles again. Angles that share that common vertex, they're opposite each other. That then allows me to say that triangle XCY is congruent to triangle SCT. What's the triangle proof here? Side angle side. And once we're able to show that this bottom triangle is congruent to the top triangle, we are then allowed to say that XY is indeed congruent to ST. What allows us to say that, though? That's the trick. And hopefully you picked up on this in the last video. If we're ever going to show that parts of a triangle are congruent, we had to say that the whole figure was congruent, which means CPCF, corresponding parts, incongruent figures. So again, we've got to show first the triangles were congruent, and then we can say the parts are congruent by CPCF. So a couple of, again, key hints they're giving away. It's a triangle, so start with the definition of a triangle and then see what else they give you, just like we did here in the first one we did, number 4. It's the midpoint, so we used definition of midpoint. You got a couple more to try today. Please really, really work hard on trying them, seeing what you can utilize, see what process you can use, and check your answers when you're done. If you have any questions, make sure that you reach out. Otherwise, until next time, everyone, stay safe.